Hi guys, so we're back and now it's time to start working on the AI tank. And please bear in mind this is not proper AI. We're just gonna try to get a tank to patrol a little bit around the map, and later on we may be making it shoot us too. But let's start with a very simple patrolling tank, okay? So the first thing we're going to do is we're going to duplicate the tank prefab, change the name, we're going to call it AI tank. Let's see if we can find a material to change this or something. Oh, that's it, tank color, tank rate, tank lights, tank. Is there no like a pink or something like that? I don't know. Yeah, blue seems alright. So let's make this tank blue. And you see, we have a blue tank that we're going to be using for our AI. So the first thing we're going to do is we're going to remove the tank controller. We're going to save this, and then we're going to go back here. We're going to create an AI tank controller. So we're going to create a new C# AI tank controller. So the first thing we have to ask ourselves is, what do we want to do with this AI tank? So tank controller is going to move the tank around following predefined path. Later we may want to do more stuff, things like if the player is near enough, the tank will stop and shoot at the player, for instance. I don't know, I mean, we can think of more things to do, but right now let's leave it like this. It's very simple, very easy to do. So okay, we want the tank to move around in a predefined path. So we could have waypoints. We could have, I mean, there are different ways of implementing the path, but I want to show a way of doing it that is very hands-on. I want you to understand how a simple path following AI behavior works, okay? In order to do that, what we're gonna do is we're gonna do a very simple version of this without using the AI tools that Unity provides. Instead, we're gonna define the path as an array of transforms. We're gonna call them waypoints, and they're gonna be defined by the player. And we also want to define what's the distance. For instance, I don't know, 50. No, I don't know. We'll do this later. So now that we have something basic defined here, let's configure it in Unity, and we'll see. So the first thing we're gonna do is we're gonna add the AI tank controller. Okay. Gonna save. We're gonna add an AI tank here. So add an AI tank here. So instead of now we're gonna create an empty. We're gonna call it enemies. We're gonna put the AI tank, and we're also gonna create like patrol 1, and everything. Oh yeah, well, let's make these. It's kind of annoying when you have things that are not in the 000, which is where we want things to be. So put the enemy's route in the 000 and the patrol in the 000 patrol route. And now we create a set of waypoints. Point 1, we're gonna be for instance 10, 0. We're gonna create a waypoint 2, which we're gonna put here. Let's create waypoint 3, which is gonna be, I don't know, here. And I'm gonna create a waypoint 4, which is gonna be, I don't know, here. Now in the AI tank, we need to pass the waypoints. So there are several ways of doing this. We can go one by one, adding it to the waypoint, like drag and drop. But instead, we're gonna do something different, which is quite convenient when we have a set of things that we want to assign to an array. We just click this lock button, which means that we're gonna keep these object in the inspector. Then we select all the waypoints, drag and drop them in the waypoints array, then we can unlock it. And here we go. That's cool. This is nice, but it is kind of annoying that we don't see where the tank is going to go. I mean, wouldn't it be good if we had the waypoints, the patrol route visible when assigned to this tank? I think it'd be good. Let's do that. Let's draw it. We can define a onDraw gizmos. So this method, we define this method, which actually is it's an event. It's a response to an event. This will be called every tick in the editor, and allows us to draw things that are only going to be drawn in the editor view, in the scene view. So we can say something like color equals color cyan, and then for int e equals 0, that's equal then waypoints length I. Next I is I plus 1 module waypoint length, and then we draw a line. So gizmos, draw a line, waypoints I, waypoints next I. This is basically that's position. Basically what this is doing is to drawing a line between each of the waypoints and the next one, which is basically drawing the route in cyan. So if we've done it right, now you see our route appears, we could have so one of the things that we need to do is to define when we decide that we have reached a waypoint. So this to waypoint, to advance. So this is the distance to the waypoint, so the next waypoint, to decide that we are close enough and we have to go to the next one. And we can do something about it. So for instance, we can draw the lines in cyan, but we can draw in green sphere in the center, waypoints, and the radius is going to be these two bands. So this way we're drawing a sphere at every waypoint. So you see when we're going to be moving on to the next one. And it also allows us to better see where the waypoints are. So when the tank, the center of the tank is within this sphere, then it goes to the next one, then goes to the next one, and so on. Good, but this is not going to do anything. This is not moving the tank now. By the way, if we're going to be having this tank, maybe we want to move this a little bit further apart so that we can see it. Something like this. Yeah. Problem is the tank is not moving, and it's not moving because we haven't configured that part yet. So we must, so I don't think we're going to be needing the start. We only need the update, because at least so far we don't need the update. Actually, no, forget about it. So, I mean, so you would think that the best way of starting this is going to the first waypoint first. But maybe later we may decide, okay, how about instead of doing that, we go to the nearest waypoint, and from there we go on normally. So obviously, in any case, we're gonna be, so at any point in time, we're moving towards a certain waypoint. Okay, that means that we need to store the next waypoint, and by default, we're gonna have a 0. So what we have to do is set the inputs based on the direction the tank has and the direction to the point we want to go, right? So the thing is, the inputs are going to be the same that we're using for the player. So when the player is if the player is pressing left and right, what it does is it rotates the tank. And if the player presses forward or backwards, then the tank accelerates or decelerates, or even goes backwards. So we're not going to consider the option of going backwards, and instead what we're going to be doing is we're going to be considering, well, let's start easy. We're going to consider that the tank is always wanting to go full speed. So how do we do this? We basically said that the inputs 0.0 and 1. That's going to be. We still have to calculate the steering. So we'll have to calculate the steering. In order to do that, we need to calculate the angle between the current the current direction and the direction to the point. And we're only interested in the angle in the XZ plane. So the first thing we're going to do is we're going to have a next waypoint, but actually we're going to keep a vector 3 because it's going to be easier to do the calcs. Waypoints position minus the waypoint position, the current waypoint, the next waypoint minus the current position. And the direction is a transform forward. Maybe now we can use vector 2s. So yeah. And in the direction the XZ is in the vector 2. X.C, right? So the thing is, we want to steer right if the direction is toward right. That means that the angle between them is positive, and we want to steer left if the angle is negative or bigger than 180. How do we do this? Okay, so if you think about it, the angle is going to be positive if the sine of the angle is positive. The angle is gonna, if the sine of the angle is negative, the angle is going to be negative. There is a correlation, sorry, a one-to-one correlation. So we can first calculate the sine of the angle with the cross product, and then we can we see if that is positive or negative, and use the sine to calculate the angle, the actual angle, using an arc sine. The thing with that is we have the vectors. So in order to do a cross product to the vectors, it makes no sense because you get another vector. But we know that vector is going to be in imagine it's in the those two vectors on the XZ plane. The third vector that you get doing a cross product would be in the y-axis. So actually, it may be a good idea to leave it as a vector 3. Screw that, yeah, next pause, minus pause. And then we do a vector 3, cross is vector 3, cross. And that's the next pause. Okay, so there to next pause dot y is 0, there dot y is 0. need to normalize them. And then we can do the cross. And then the angle is going to be the arc sine of cross dot y. With that angle, we calculate the steering anything a2 minus 1, 1. We want to ensure that the angle is in the range minus pi, pi. Now, we can also float steering sensitivity, which we're gonna leave in, for instance, 2.0. This is only the factor when we multiply the angle between the current direction and the ideal direction to calculate the steering. That's what we get, and we limit it to range minus 1, 1. Finally, not finally, actually, this is going to be moving the tank towards the next waypoint. In theory, right? Let's see if that's what is happening. Maybe I made a mistake. I mean, to be honest, maybe I made a mistake here. Maybe we're steering away from the next waypoint. I don't know, man. Maybe I just made some mistake in the calcs. I don't think so, but it's good to be testing every few lines of code that you write. So in here we can press play and let's see what it does. Well, yeah, it does nothing. Okay, and that's right because yep. Because I'm not passing these inputs to the movement controller. I'm not passing the inputs to the movement and controller. So again, we're gonna rename the movement and controller. And we need to calculate this, sorry, to get this in the start. Yep. Looks like it's not working well. So let's see what's happening here. We're gonna be debugging this, okay? So, and we're gonna, it sort of worked a little bit, but not quite. So, let's have a breakpoint here. What's next? And then, so. We have next pause, which is in there. We have there which is that one, and then steer to next boss, which is that one. And we normalize the directions, and here we go. So direction is 1, and the direction to the next point is another 1. So the cross product is going to be minus 0.9. The angle is going to be minus 1.23, which is correct. And then the thing is, the angle is still negative, so it's going to be, the input's going to be minus 1, which is right. So it's going to be moving to the left, but we want to move to the right. So most likely I made a mistake there. In how we calculate the angles. So probably the cross product is the other way around. I just want to check. So yeah. So we have a direction. Cross product is 0 because they are in the same. Direction is the opposite. Shouldn't it be? It should be 180. Oh yeah, but the yeah, the problem is with the cross product, we only get an angle in the range from minus 90 to 90. I thought that would be enough, but it looks like it's not. So maybe what we want to do is get the dot product too and calculate the proper angle. So let's see if at least, I mean, this probably should go here. So probably do it like this. I mean, for the dot product, it's really the same. It doesn't change whether you put it one way or not. It's kind of like, it's nice to have both things in the same way. So yeah, let's see if this works better. Yeah, it looks like it is. It's actually working the right way. Yep. Problem is it's always going to the, so if we put it like this, we see that the tank is always going to the same waypoint. So now we have to go and change the waypoint when we reached it. That sounds simple enough, right? We just have to check. So anyway, this is starting to be a little bit long, right? So let's add a function to it. Private void calc, actually, so to calc move inputs. This function returns the movement inputs to be used based on the next waypoint. Basically, want this part here we want something like this. I like it. Right, let's write it properly. So now we have moved this out of this function into a different one, which simplifies things. And let's also check So basically we calculate the distance this to next waypoint, but squared because as you know, the number of operations that you need to do to calculate a module of a vector is basically a square root, 2 additions, and 3 multiplications. Of the 6 operations, the most expensive one by far is the square root. We can avoid doing square roots. It's gonna be generally a good thing. It's gonna make the code more performant. So, if in this case there is no reason not to do it, since we're gonna be doing a comparison, we can, do multiplications and multiplication and avoid the square root. Yeah, I think it's a good trade-off. So what we do is we say waypoints next waypoint position minus transform position square magnitude. If to next waypoints is lower or equal than these two waypoint to advance squared, then next waypoint is next waypoint plus 1 module waypoints left. This basically checks if we're close enough to the current waypoint to go to the next one, and if that's the case, it changes the waypoint to the next one. Let's see. Let's see in the scene. It looks cool. It seems to be working. One of the things that we could do is we could slow down when the angle is too tight, is too big, so that it kind of like slows down to take big turns, and then accelerates back when there is a straight line. But actually, I'm going to leave that as an exercise for you. So yeah, please try to try to change this algorithm so that this tank slows down when it gets to the next waypoint. You could also, if you want, draw what's the next waypoint with a line to the next waypoint and your current direction, so that you can see how it changes. Maybe the inputs, I don't know, you could add some debug info to draw gizmos to make it simpler to understand what the AI tag is doing at any point. And also I've realized that I still need to fix the aiming of the tag, which is something that we left undone in our last video. Definitely I'll be doing that in our next video. Maybe it'll be a small one, but I'll make sure that's fixed. Anyway, thank you for watching this tutorial, and I hope to see you guys again in the next video. Bye.